In this video, I'm going to show you how to solve a circuit using Laplace Transform with the TI Nspire. In this circuit in front of us, we have to solve for V0, but for this circuit specifically, in order to solve for V0, we're going to have to take the Laplace Transform of this circuit and solve this circuit in an S domain, and then take the inverse Laplace of the relevant equation. In order to do all that, we must be familiar with the equations for components in the Laplace domain. In front of us, I have a chart with all the equations for components in time domain on the left and in S domain or Laplace domain on the right. If you're not familiar with these equations, please pause the video and write them down so you have them available for future reference. In order to solve this circuit, we must convert every component into the Laplace domain using the equations that I just provided. Starting with the voltage source, the equation is going to be 325 over S. The equations for the resistors do not change in Laplace domain, so this resistor is going to remain as 250, this one is 250, and this one is 500. The equation for the inductor changes very slightly. It's going to be 625 millihenries times S. And for the capacitor, it's also going to change very slightly. It's going to be 1 over the capacitance, 800 nanofarads times S. These are the main changes going forward. I'm going to use simple EFC KCL to solve this circuit. At the end, I'm going to use inverse Laplace to get the relevant equation back into time domain. So now I must label the nodes and the currents. So I'm going to label this node down here as my ground. The voltage up here is going to be 325 over S. I'm going to say that this voltage is VA, and the voltage here is going to be VB. I'm going to say that this current is I1, this one's I2. This current going all the way over here is going to be I3. Let's say that's I4. I5 and I6. So now we're done labeling. So now we have to move on to KCL. So there's 3 nodes that we care about. I'm going to call this node A, node B, and node C. So when doing KCL, we're going to have 3 nodes. So node A, I'm going to call it. I1 goes into it, and then I2 plus I3 come out. In node B, I2 goes in, and I4 plus I5 come out. In node C, I5 plus I3 go in, and I6 come out. And that would be all the KCL we care about. So now we're going to do our EFCs. So I2 is going to be equal to 325 over S minus VA over 250. I3 is going to equal 325 over S minus VB over 1 over 800 nanofarads times S. I4 is going to equal VA over 500. I5 is going to equal VA minus VB over 250, and I6 is going to equal VB over 625 millihenries times S. Now there's one main equation that we're missing here. Remember, the question was asking for this current, voltage, which is called V0. So we have to represent that in our system. So we're just going to add another one. So V0 is going to be equal to 325 over S minus VB. So we just write that down. So now we have our complete system of equations, and all we have to do is plug it into the calculator. So to plug this system of equations into our calculator, we pretty much follow the same procedure. However, if you start counting out how many equations and variables we have, you might think that we might run into a problem. If you count out the number of equations we have, you'll notice that we have 9 equations but 10 variables. Now this normally means that we can't get the solution. But remember, we're in S domain, so all of our answers must be in terms of S. So it's no big deal that we have one less equation that we have variables. It's fine because we want all of our variables to be in terms of s. So the way we would represent this in our calculator is that we simply just go to algebra, solve system of equations as we normally do. We write down the actual number of equations we have. And when we start writing down our variables, we just don't include s. We write I1, I2, I3, I4, I5, I6, VA, VV, V0. We just don't write s, and that's completely fine. If we don't write s here, it's going to treat s as a constant, which might seem counterintuitive, but it's going to allow all of the variables to be expressed in terms of s, which is exactly what we want. So we simply press OK, and then we just start putting in our system of equations. So I'm going to start with my KCL. So I1 is going to be equal to I2 plus I3. I2 equals I4 plus I5. I5 equals I5 plus I3 equals I6. I'm going to move over to my EFC. So I2 equals 325 over S, just write S, no big deal, minus VA over 250. Then I3 is going to be equal to 325 over S minus VV over 1 over 800 nanofarads times S. No big deal, you can just type that constant there, no problem. Then the next one, I4, is going to be equal to VA over 500. I5 is going to be equal to VA minus VV over 250. And I6 is going to be equal to VV over 625 micro times S. Last equation is going to be V0 is going to be equal to 325 over S minus VV. So this is my system of equation. I'm going to scroll through it real quick. As you can see, all my equations are there. And we simply hit enter. Once we hit enter, it's going to express our every single variable in terms of S, which is completely fine. So this is our V0, which is what we want. So I'm going to write that down on a piece of paper because we are going to have to find the inverse Laplace of that equation. So according to the calculator, our V0 is equal to 325,000 over S times S plus 1000. So now all we would have to do is simply just take the inverse Laplace of this equation, and we would have our answer for V0 in the time domain, which is exactly what the question is asking. To get the inverse Laplace of this equation, we must first express this equation in partial fractions form. We have to express it in partial fractions form because the inverse Laplace is very easy to calculate if the desired equation is already in partial fractions form. So a partial fraction of this is going to be equal to k1, some constant, over s, plus k2, some other constant, over s plus 1000. So we could do a simple system of equation on this to solve for k1 and k2. We would just plug at least two values in for s and plug that system into our calculator to get k1 and k2. But actually our calculator can directly solve for k1 and k2. The way it would do that, it was just go to menu, then you go to algebra, then you go to expand, and then you just type in our current equation, which in this case is going to be 325,000 over s times open paren s plus 1000 close paren. So we hit enter, and that's going to give us our k1 and our k2. So I'm going to write that down. It's going to be equal to 325 over s minus, you got to be careful with the minus sign because it's very easy to overlook it, 325 over s plus 1000. Now it's very easy to calculate the inverse Laplace from this form. The inverse Laplace would simply be 325 minus 325 e to the minus 1000t. And that's going to be our answer. That's going to be our v naught in time domain.